Today we are going to start Unit 15, Molarity, pH scale, and strengths of acids and alkalis. Before I start, I need to clear that I'm having some technical problem when converting Word version into this PDF file I'm using to make the video. So you can see some of the format have changed. The superscript and the subscript have moved its position. It won't affect your understanding, but do refer to the Word version for the accurate format. So, in this lesson, I'm going to introduce a very important concept to you, which is concentration. Okay, so in this unit, we focus on the concentration of a solution. So, a quick revision of what a solution is. So, imagine we have a beaker of water, and then we put some sodium chloride in it. Okay, put some sodium chloride powder in it, and after we put them in, and then we stir the solution. Okay, we stir the solution, and then after the sodium chloride have dissolved in those water, then we get this what we call sodium chloride solution. Okay, so in this solution, we have sodium chloride as a solute. So that's the thing that we put in. And we have water as the solvent. Okay, so these are the two key terms that you need to be clear before we move on to the next part. Okay, so remember, in last unit we have touched on what concentration means. I told you concentration is a way to describe how many things we have put into the water. Okay, so in this unit we have an accurate definition. So for concentration, it's talking about the amount of solute per unit volume. Okay, so in order to work out the amount of solute per unit volume, then we can use this formula. Okay, so the concentration equals amount of solute over volume of solution. So the next question gonna be, okay, how we express this amount of solute. Okay, so first of all, okay, the first way to express it is in terms of the mass. Okay, so a common expression for concentration of a solution can be in gram per dm cube. Okay, that means in 1 dm cube, how many grams of solute we have adding. And usually in this unit, okay, the volume would not be given directly in dm cube, so you need to do unit conversion. Okay, so there are some common units that you need to be familiar with. First, 1 dm cube is equal to 1,000 cm cube. Okay, so if we are converting cm cube to dm cube, we need to divide by 1,000. And also, in daily life, we normally use liter or milliliter to describe the volume. Okay, so liter is equivalent to dm cube, milliliter is equivalent to cm cube. Okay, so now we can turn this equation into the one that we have below. Okay, so the concentration in gram per dm cube equals the mass in gram over the volume of solution in dm cube. Okay, or if we want to use letter to represent it, it would be concentration, we use lowercase of c to represent it, equals mass, we use letter n, and for volume, we use v. Okay, so that's a way to express the concentration in gram per dm cube. So let's take a look at how we can apply this formula to find out the concentration. Okay, so in this unit, when you're reading the question, please use a highlight pen to highlight the unit because sometimes it can remind you to convert the unit before you do calculation. So take a look at the first example. 5 gram sodium chloride is dissolved to form a 300 cm³ solution. So the concentration of the solution is, okay, so mass in gram, but volume in cm³. Okay, so we need to convert that into dm³ first, okay, by dividing 1,000. So remember, concentration equals mass over volume. So it will be 5 gram over 300 divided by 1,000, or times 10 to the power of minus 3. Okay? So the final answer will work out to be 16.67 gram per dm³. Okay, again for here, we leave 2 dp. Okay, that would be enough. Okay, then, but sometimes, okay, normally, if we take a look at the label of your drink or some label of the drug you take in, it will be expressed in terms of ml or milliliter or liter. Okay, so how can we calculate the concentration for those labels? Here is an example. In this picture, the paracetamol is prepared with 250 mg of paracetamol dissolved in each of 5 cm³ of water. Okay, so what is the concentration in gram per dm³? Okay, here the mass we have is in milligram, so we need to convert that into gram first, and then the volume we have is in cm³, and we need to convert that into dm³ first. Okay, so the mass of solute 250 milligram, so it would be divided by 1,000 and turn into 0.25 gram. And volume of solution 5 cm³, again divided by 1,000 or times 10 to the power of minus 3. That would give you 0.005 dm³. And then now we're ready to calculate the concentration. It would be the mass and divided by the volume. Okay, and then it will give us the final answer, which is 50 gram per dm³. Okay, so if the bottle contains 50 cm³ of the paracetamol, what is the mass of the paracetamol dissolved in the solution? Okay, remember the formula I gave you is to work out concentration. Concentration equals mass over volume. So we can modify this formula a little bit so that we can work out the mass of the solute is equal to the concentration multiplied by the volume of the solution. So to do that, so the mass, okay, would equal to the concentration which we have worked out in part A, which is 50 gram per dm³, and then times the volume. Okay, again here we have the volume in cm³, so make sure you convert that to dm³ first. Okay, so 50 divided by 1,000 or multiplied by 10 to the power of minus 3. Okay, so you have to get used to this kind of expression. And then, if we work out the answer, it will be 2.5 gram. On the next page, we got 4 checkpoint questions. So please pause the video here, complete the questions first, and then look for explanation. So here, I will pick question 2 and question 4 to go through it with you. And for question 1 and 3, you can refer to the question at the back of the notes. So take a look at the second question. On the right shows the nutrition information label of a lemon tea drink. What is the concentration in gram per dm cube of sugar in the drink. So let's take a look. Sugar is at this part. Okay, so, and that's 13.6 gram per 100 ml. Okay, so we need to convert the unit into dm cube first. Okay, so in order to calculate the concentration, we need to apply the formula concentration equals mass over volume. So it will be equal to 13.6 gram over 100 ml in ml, but we need to convert it into dm cube. So we need to divide it by 1,000 or multiply by 10 to the power of minus 3. Okay, so it will give us the answer, which is 136 gram per dm cube. Okay, and then for question 4, given the concentration of sodium chloride in seawater is 35 gram per dm cube, calculate the volume in cm cube of seawater, which contains 8.75 gram of sodium chloride. So if we take a look at the formula we have, concentration equals mass over volume. Okay, so the volume should equals the mass divided by the concentration. Okay, so volume of the seawater equals mass, which is 8.75 gram over 35 gram per mole. Okay, so that will give us 0.25 dm cube. Okay, remember the question asks you to express your answer in cm cube, so you must convert the unit. Okay, so to convert from dm cube to cm cube, we need to multiply by 1,000. So it will be 0.25 times 10 to the power of 3, which equals 250 cm cube. Okay, so make sure you always write your unit at the end of your calculation, otherwise you will lose marks. Now I'm going to introduce the second way to express concentration. Okay, remember in Unit 12 we have introduced a new concept, mole. Okay, in chemistry. Okay, in chemistry we use mole a lot to express the amount of substance that we have. So we can also express our concentration in terms of mole, okay, the amount of substance divided by the volume. So for this special type of expression, we also call it the molar concentration or molarity. And the unit for molar concentration or molarity are mole per dm cube. Okay, so how many mole of substance in 1 dm cube of solution? Or simply, sometimes we use a capital M to represent the unit. Okay, so the capital M means mole per dm cube. Okay, so if we want to calculate the molar concentration or molarity, how should we do? Okay, here is the formula that we use. Okay, molarity, the mole concentration, equals number of mole of the solute over the volume of the solution. Remember, the volume of the solution need to be in dm cube. Okay, so we can also express this using the letters. So if we use letter to represent it, again, the concentration you can use letter lowercase c, or for molarity we can specially use capital M to represent it. Okay, so it would be M equals number of mole, okay, we use lowercase n, and then over the volume of the solution over V. Okay, so sometimes we can also modify this so that we can get this equation, this formula. So the number of mole equals the molarity multiplied by the volume of the solution. Okay. So in the lab, you will often see these labels on the solution. Okay, it's very important that every time when you get a new substance, you read the label. Okay, remember last unit we mentioned when we are dealing with concentrated acid or concentrated alkalines, because they are corrosive, so we need to pay attention to it and wear the protective gloves and wear safety goggles. Okay, so let's see some examples how we apply those formula. So the first one, we have 30 grams of sodium carbonate and they are dissolved in water and the solution is made up to 100 cm cube. Okay, so calculate the molarity of the solution. Okay, so the mass are given in gram. So from here, we would be able to work out the number of mole. And then the volume is given in cm cube, so we must convert it into dm cube. Okay, so remember in unit 12 we have learned, okay, from the mass, when we divided by the molar mass, then we can get the number of mole. Okay, so to calculate the molar mass of sodium carbonate, we just need to add the relative atomic mass for each atom. So it will be 23 times 2 plus 12 and plus 16 times 3. Okay, so total it will be 106 gram per mole. Okay, so the mass divided by the molar mass, and then it will give us the number of mole. Okay, remember, if it's not the final answer that we take, it better take more decimal places. Okay, definitely more, at least 3. Okay, and then the last step. Now we got total number of mole, which is 0.283, and then we should divide it by the volume. Okay, volume we have is 100 cm cube. Remember, when we convert it to dm cube, we divide 1,000, so it should be 0.1. Okay, so the final answer is just 2.83 mole per dm cube, or you can say it's 2.83 molar. Okay. Again, on the next page, we got 3 checkpoint questions. Okay, so please pause the video here and attempt the question first. Question 1 is pretty standard, so you just follow the method that we used to work out the answer for the example question. So I will go through question 2 and 3 with you. So for question 2, a solution is prepared by dissolving 30 grams of potassium hydroxide into water. Okay, so it's given us the amount in terms of mass. And then calculate the volume of the solution if the concentration of the solution is 0.5 molar. Okay, so 0.5 mole per dm cube. Okay, so remember the formula that we have learned. We got molarity equals number of mole over volume. So here it asks us to calculate the volume of the solution. So the volume of the solution should equals number of mole divided by its molarity. Okay, so here the molarity have already been given in the question, 0.5 molar. However, we do not have the number of mole, but we have the mass. Okay, so we can work it out. Okay, so mass should equal number of mole times the molar mass. Okay, which means the number of moles should equals mass over molar mass. Okay, so mass is directly given 30 gram, and it should divide it by the molar mass, which equals 39.1 plus 1 plus 16. Okay, so that will give us the number of mole, which is 0.535 mole. And then we can use this equation to work out the volume. So the volume should be number of mole 0.535 divided by the molarity 0.5, and then it will equal to 1.07 dm cube. Okay. For question 3a, find the mass of potassium nitrate would be required to prepare 500 cm cube of 0.1 molar potassium nitrate solution. Okay, so here, remember the formula, molarity equals number of mole over the volume. Okay, so here, if we want to work out the mass, we need to first work out the number of mole. Okay, so if we rearrange that formula, number of mole should equal molarity multiplied by the volume. Okay, so here, molarity 0.1, we can directly use it. But for number of mole, it's in cm cube, so we need to convert it into dm cube first. Okay, so 500, it should be divided by 1000 to convert it into dm cube. Okay, and the answer should be 0.05 mole. And then from number of mole, if we need to work out the mass, we need to multiply by its molar mass. So the molar mass for potassium nitrate would be 39.1 plus 14 plus 16 multiplied by 3, okay, which total would be 101.1 gram per mole. Hence, we could finally work out the mass, which equals number of mole multiplied by molar mass, 0.05 multiplied by 101.1, okay, which is 5.055 gram. Okay, so last one, I want you to pay special attention. Okay, so you need to I want you to put a star next to this. Here, it asks you to find the concentration of 0.1 molar potassium nitrate solution in gram per dm cube. Okay, so there are two ways to work it out. First, okay, since we know the mass, okay, which we have calculated in part A, and then we also know the volume, okay, so we can use the mass to divide it by the volume to work out the concentration in gram per dm cube. But we also have another way to do it. Okay, so which is one that I recommend you to take this approach. Okay, so remember, we know number of mole equals the mass equals number of mole multiplied by molar mass. Okay, and we also know molarity is, okay, so molarity is number of mole over volume. Okay, so we can actually express the number of mole here in terms of the molarity. Okay, number of mole in terms of molarity. Okay, so number of mole should equal molarity multiplied by the volume. Okay, and then we can substitute that in to our first equation. Okay, so that means mass should equal the molarity multiplied by the volume and then multiplied by molar mass. Okay, and then if we rearrange this equation a little bit, okay, so we move this volume to the left hand side. Okay, it will become the mass over volume equals molarity multiplied by mR. Okay, so on the left hand side here, this part is what we are looking for, the concentration in terms of gram per dm cube. Okay, concentration in terms of gram per dm cube. So the quicker way to work it out is to use this molarity, which is here, multiplied by the molar mass. Okay, so then we can convert the molarity into the concentration in gram per dm cube. Okay, so the easy approach to do this is the molarity 0.1 multiplied by the molar mass we have worked out in part A, which is 101.1. Okay, and then it will give us the answer, so it will be 10.11 gram per dm cube. Okay, so please highlight this formula, okay, because you're gonna use it quite often in later calculation.